So welcome everybody. Hope you had a good lunch. It gives me great pleasure to welcome Anne to the DB2 stream presentation floor. He's got a very interesting sounding presentation, SQL performance monitoring with analytics and interactive visualization through Grafana. Now, I've played about with Grafana a while ago, so I've got a little taste of what it can do, and I'm quite interested to see what Anne has to say to us today. So welcome, Anne. Tell us a little bit about yourself. Oh, just a minute. Don't forget, everyone, the session number is 6P. We would greatly appreciate your feedback. And towards the end of this presentation, we will have a couple of words from Frank Bakker from IBM. He's a co-host. He's been helping Anne with this project, and he will give us a little bit of background after the main presentation. So thanks everybody.
Thanks, Marcus, but not from IBM, from UBS Heine.
Oh, sorry.
No problem.
My apologies.
Okay. No problem.
UBS Heine. Okay, sorry. Yep. So thanks, Anne. Over to you. I shall turn my video off because I don't want to distract anyone.
All right, thank you. So hello, everybody. Today, I'm excited to bring the topic to my presentation on how you can monitor, analyze, and interactively visualize the performance of the SQL queries using Grafana. And yeah, to start, in short introduction to myself, my name is Vian Liu, and I'm 23 years old, and I live in Cologne, Germany. I have studied computer science at the Heinrich Heine University in Düsseldorf, and with a focus on databases. And I've been working as a DB2 administrator on the US for Rewe Digital for 2 years now. And in my role, I've been primarily responsible with my colleagues for managing SQL, and with it, we developed our own dashboards in Grafana that we will see here today as well. And in this presentation, we have a focus on how we use the dashboards and how the dashboards helped us with finding bottlenecks, improvements, and trends in the SQL performance data. So let's dive into the topics, and here you can see our agenda. First, I will tell you a little bit about the Rewe Group. Then I would like to talk about our workload on our DB2 and how we use SQL in Grafana. And additionally, I've prepared an example that demonstrate how we can analyze the performance of the SQL queries and show you the zonal benefits that we have with Grafana. And moreover, we have a special treat with you. As said, Mr. Frank Bakker from the UBS Heine will explain in detail how SQL works. And finally, I'm happy to answer any questions you might have during the presentation. Yeah. And so dive into, to start with, the Rewe Group. What is the Rewe Group all about? My company is primarily focus lies within the realms of commerce, e-commerce, and tourism. That means everything from food, shopping, do-it-yourself projects, essentially everything what you need, we got to cover with. And what does it mean in number of terms? The Rewe Group has approximately around 93 billion euros of revenue, and we are happily proudly employed around 400,000 people. And yeah, our networks span across around 16,000 stores and travel agencies. And here you can see a little footprint where we are located in. You can see we are primarily located in Germany, but as well across Europe, like Austria, Croatia, Finland, Poland, France, Italy. You can find subsidiaries all over Europe. Okay, and for completeness, I've once again listed here the subsidiaries of the Rewe Group. Perhaps might of you be familiar with the Rewe grocery store, Penny grocery store, or other subsidiaries you can see. But today we are only focusing on the Rewe grocery stores and Penny grocery stores because the two branches mainly produces all the DB2 workload, and so our architecture is primarily used on the German market. Okay, so let's dive into the workload. To start with, I want to talk about our system environment, but first of all, why is the performance crucial for our business success? And there are 3 main points. everything from the grocery stores, warehouses, intermanagement like item controls, accounting, reporting needs our DB2 in the US. That means if our system has a bad performance, everything slows down and costs our company a lot of money because the worker can't walk fast as they would like, and the trucks cannot deliver the food to the warehouses, and the warehouses can't work efficient as they should. That means everything has performed well toward the daily business. And on the right here, you can see a little picture bring to you. You can see everything, every task needs our DB2 as a data supplier. So you might ask yourself now, how large is our environment and how much do we need to have to control with and have an overview over the performance. And yeah, we control about like 25,000 property tables and 120,000 packages all on 900 terabyte of active storage. And additionally, we have a feed test system as well, and that are handling around 1.4 petabyte of storage. And our DB2 system environment is reaching peak levels about 140 billion SQL executions per day. And this workload is distributed across 12 DB2 subsystems, prompting the question how we can ensure the stable performance and how we can monitor and evaluate the performance on all our DB2 subsystem, and of course overall the complete system. And this solution brings us to SQL QC. Okay, but what does SQL QC do? SQL QC analyzes the current workload and provides suggestions for improvement. That means we're able to keep track on all the SQLs which are executed on our DB2. And we have a standardized method for the SQL quantity. And this means we are able to identify SQL that are not performant, and we can quickly improve the SQL and to find bottlenecks, or we can create missing or can create indexes to to hold a better performance. And yeah, to give you a brief impression, I will now briefly explain how SQL works, but Frank will give you more detailed information about how SQL QC works at the end of my part. So yeah, how does SQL QC manage to keep track on the performance? SQL QC reads every 50 minutes the DB2 statement cache and writes a collected statement out into a DB2 table. This is about 15,000 different statements per subsystem, and these statements are executed like 1 million times in these 50 minutes. That means these 15,000 statements on each subsystem multiplied by 12 members, that's around 180 rows, which are written out in 50 minutes. Yeah, so due to the massive workload, we need to aggregate it more, because in 1 hour, we have like up to 600,000 rows. And if you want a quick performance report, you need to aggregate it even more. So we can update the plan. And you can have a plan. So we can aggregate it hourly and daily. And yeah, we can have it hourly and daily for the performance analysis, even to conduct the evaluations like Grafana. And this aggregation is total about 300,000 rows per hour, and per day are like 1.7 million rows we are inserting in the aggregation table. So you can see the aggregation is necessary for the performance reason and to hold a clean overview about the performance. But this is not the only task SQL does for us, because SQL runs explain job every 3 hours and explains our most executed or most CPU intense SQL queries. That means we can keep track on the access path changes. You can see if the access paths get worse, get better, or didn't change overall. But due to the heavy workload, of course, we cannot automatically explain everything by collecting. So we planned our complete run on the weekend, where the workload is very light. So we have a complete overview about the access paths on the whole system. But the main question is now how we can handle such huge data and how we can bring a high abstraction, so we can see the fast performance issues. And this brings us to SQL to Grafana, sorry. So why did we choose Grafana? First, Grafana is open source, so that means we haven't to pay for it, and with a high abstraction via metrics, we're able to see bottlenecks in 0 time. Secondly, you don't need to write SQLs or connect you to a DB2. It's a web application, so it's system independent and it will run everywhere, like mobile phones, macOS, Windows, all on the operating systems you want to use this. This has a web browser, of course. And the main reason is the capability of detection of irregularities. That means we have metrics, we can have the high abstraction to see bottlenecks or performance issues. But now let's dive deeper in and how we do it and how Grafana provide the data and how does it work. So how does Grafana work? It works like we have a DB2 table you can see on the left with the data, and Grafana takes the data and transform it into metrics. You can see on the right. So in the table you can see hardly is there any performance issues, is there any irregularities, and on the left, on the right, you can see a very nice graph. You can look at it and you see on the June 2 there's a good performance, a bad performance. Something has changed, and that is the important thing. You can see on one point of looking at it, everything is different. So we take this idea and build us our own dashboards to ensure from each application that we use in our company. And that brings us to the next point, the performance list. So this is our main dashboard, you can see here. And to explain it in a few words, here's my mouse. On the top, you can see a Kennzeichnung. It's like an application string, the transaction string, which grouped by the applications we use in our company. It's like you can click on it and it will open. So you can see we have a product mainframe, product Mabu. It's like item accounting, and these products are using SQL queries and use SQLs against our databases and asking for data. And we can now group the connections to have a clean overview about the product and the product performance. So we can have a quick overview if the product has any performance issues, if something changed, if the performance is well, or if there any index missing, or can we help the performance get better. And now as example, I bring up the product mainframe. It's our own product, and on the left you can see the top 10. It's like aggregate over the whole product, all statements. You can see the important informations, executions, the CPU time, the elapsed time, get pages, row examined, row processed, wait time, and of course we have a statement elapsed per exec, a statement get page per exec, and CPU time per exec. These are the mainly points we are looking at, because if they changes, we know if the workload gets higher, we have a performance problem. If there's generally they're generally normal, we have no performance issues. So these are the main points. And on the right, you can see the average about the time range. The time range is selected here on the top. You can select any time range you want to, about 1 year, about 30 days, 20 days, it doesn't matter. The performance due to the aggregation is very well on this dashboard. So with indexes, we can have this good performance reporting. Okay, and on the bottom, if you see here, we have top 10 statements. So a list of the top 10 statements. And first, it's about the complete product. That means every SQL executed are disappear and summed up, or summed up. And after it, these are the single statements which have the highest CPU usage, the highest elapsed time, or highest executions, or highest get pages. It depends. You can sort it by clicking on the columns. And if you go further down, you can see the big picture. You can see again all the statements, and you can see the performance of the statements which are collected in the last day. And you scroll further down, we can see the metrics. If something changed or something is different to the last day, we see it here, and we can keep track on the performance and see performance issues. And of course, we have a drill down menu. We can drill down to the each application, like as you could see the hour migration, the top 10 migration, and other products. And very helpful because if you look at the graphs, the metrics, you can see the performance issues in no time. And this is what's really a good use case. But let's go back to the main points. You can see the statement ID. It's colored in blue, and it's a hyperlink. You can click on it, and you go to another dashboard. And in this dashboard, you get extremely detailed information about the statements, but it does in 1 hour, and how does it perform it in 1 hour. So if you click on the statement ID here, you can get this overview. And this is a very interesting overview because you can see all the metrics, all the informations you need to see the trends, the performance, the bottlenecks. And here you can see the executions or CPU time on 11 o'clock in the evening. In the evening, it's very high, and the other days or the day after it, it's very low. So you see something has changed here, or something is different. Maybe it's not so often executed or less executed, and this is the main reason. You can see hourly the performance data and evaluate maybe some indexes or the performance as well. And on the top, you can see the statement text. You see there which SQL has the performance data, and after it you can see the average wait time, the total wait time, the total executions, all in this time range. That means from here to here. You can select, of course, the time range on the top. It's not cut it, but here's the time range as usual. And of course, the main part of this dashboard is there any change in the access paths, and how many access paths is given by the statement. And here can you see, yes, there's a change in the access paths in last week. And in total, there are 3 access paths, but the last explain is on 12 in this date. And what does it mean? You can see now, here's an expert change. We might control data or might have changed the statement, the access path. And and we, of course, we change it because we build an indexes. We build an index to improve the performance of this query. And this I want to show you here in the next part. Oh, sorry. Of course, go back. And if you click on this statement text, you can see the complete statement text like this one here. You can see the first 30,000 chars, and you can select it and execute it in your IDE, or see what the complete statement is about. Was this part? But now go back. You can see here, if we create an index on the 4:10 on 13 o'clock, you can see the get pages are dropping like to 0. The CPU time per exit is dropping like to 0, and the statement, the elapsed time per statement is dropping like to 0. It's like a quick performance boost. You can see I created an index. The index helped me a lot because all the statements, this statement is using index, and the performance is like ultra fast. You can see here the executions, like Ausführungen in German. It's like the executions, and you can see even the executions go up. The get pages or the CPU time is quite to 0. So this is the advantage. We can see indexes that we use, see the performance, and see the resulting benefits from the performance data we collected. And yeah.
And we've got a couple of questions, if you don't mind.
Yeah, sure. You can ask me something.
So question number 1 is, how do you know that you don't miss any statements?
Our company, we have like a control. Every connection through our database to our DB2 databases is has to give a client application information. That means in this client application information by the JDBC connector has to put our product name, like product mainframe, product accounting, or so on. And we are sure we don't miss any statements in this point. So yeah, this is the main reason. Everything connected to our DB2 has to give up the to give the application information, so we can aggregate it, and there we don't miss any statements.
Okay.
And of course, we can also aggregate it not only about the application name, but also about the user who has executed this query. That means the accounting has a special user, a user ID, and we can group it on the user ID as well and see the performance from all the queries which uses the user. This was understandable.
Yeah, great, thanks. And one more question is, you say you explain regularly to see if access paths have changed. How do you identify dynamic SQL statements?
Eventually, I can say something about this.
Yeah, sure. Yeah.
Okay, good. So there is no difference between how dynamic or static SQL is handled. So what is done within SQL QC is SQL QC, the SQL text is taken. For dynamic, for example, the literals are removed, and then over the remaining text, a hash is created. This means an SQL statement is getting we can say a unique key. Yeah, exactly. Thanks. And whenever the statement is executed again, it gets the same key. So it makes it possible to find the SQL statement whenever it was executed, because you can really imagine that's a unique key, and whenever the statement is coming back, the same unique key is created and the statement is identified again. So we get a history for the statement, and we can say anytime how the SQL statement was performing. And there is no difference between dynamic and static SQL. Both are handled the same way.
Okay, great. Thank you.
Yep. No problem. Further questions, or I can't see the chat, so I'm sorry about it, because I have just one.
No, that's all for now.
Oh, okay, great. And yeah, so that's to go on, and how we can ensure this index we created is used. You might ask, okay, we see the performance dropping near to 0 and the execution time is dropping near to 0. It must have another index, but how we can ensure? And this brings up to the explains. And if you click on this field here, you can get all another dashboard where you can see all the explains which SQL QC does for us. You can see here, this is the table, and there are 2 hyperlinks. This hyperlinks, if you click on this hyperlink, it's like the query number, and you can see here then another dashboard which is popping up. It's like the explain, the normal explain, just a little bit better, because we can replace the normal IBM standards with free text. That means we can see index can be placed within index, or the prefetch. Normally it's like S, L, or R, or R. It's better for the developers, because they can see fast if the index is better, if the match code is higher. You can see we can color the different items in different colors. and we can be sure that the index we created is used, because here you can see index is used, another index, and another access path is used as well. Yes, and this brings us to SQL in detail. If you don't have any questions for it, that was my part for now. So we'll give to Frank Bakker now.
Okay, so I can take over. So in detail, it's probably too much. I have some slides prepared just to give an overview of what SQL QC is doing, how it works. Just a second, please let me share. So do you see my screen?
Yep,
Yes.
that's good.
Okay, good, thanks. Good. Some short words about SQL QC, the product itself, so what it is. It has some components. Ant was already displaying some of them. There is a data collector. Of course, we need data to identify the SQL statements and process the statements. It's a batch process now. In the past, it was always a starter task. Now we simplified it. It's a batch process. As I had said already, whenever a statement is executed, it gets a unique identifier, so we can track the statement over time. I think that's one of the most important parts here, because tools like this, it's important that you have an overview about the trends in the statements to see what was executed in the past, which index was used, and so on. Another component is the explain component, as well a batch process. It can run anytime. So for example, Rewe is running this process typically on the weekend. Some of the statements, the most expensive ones, probably are processed daily. So for each statement and for each execution of this explain, we get an access plan, and we get an access plan history. I think that's crucial here, because to recognize if something was changed in the access path, you need the history of the plan, of the access plan. Another component is the index advisor. So the product comes with an index advisor, which means the workload is investigated. Yeah, you can assign filter factors, for example, which should be explained, which databases, which user IDs, and so on. So based on this information, the index advisor is taking the SQL statements and is looking for optimization opportunities automatically. And then finally, what we have seen already is a GUI, the Grafana GUI, which has, from my point of view, a big advantage because it's very simple to be expanded. We have seen some panels which were created by Rewe. So just having the infrastructure of Grafana and DB2 connection available, I think it's very easy to create own reports and expand existing one or modify existing ones. Very good product from my point of view. Grafana is really a good help and an excellent visualization tool. Here's some examples just to show what SQL QC in detail is doing. So what I mentioned, the first graph, for example, is showing us a history of an SQL statement. So what happened here, the statement cache, dynamic and static, they are captured. The keys are created for the statements, the unique identifiers for the statements are created. And so whenever the statement is running again, we will recognize it, and then we have a history of the statement. So for example, the green line here at the top, that's the elapsed time of the statement. We see that it is increasing for some days and suddenly it's dropping down. The same happens with the CPU, it's going down, the IO weights are going down, and so on. So what happened here in the background, index was created, and after the index creation, the statement was performing much better. So that's the first picture here. But that's enriched by other statistics, which are as well part of SQL QC. For example, the first picture on the second half of the screen, where we see the sync wait IOs, for example, the asynchronous wait IOs. Yeah, it's exactly what we saw in the first picture. They are going up. Then we created the index. Sync IO and async IO is going down to a reasonable level and then continues on this level. The next picture, for example, is showing us a buffer pool hit ratio for this specific statement. So we have two lines here, one as warning, one as critical. So we see how the statement is behaving over time, how the buffer pool hit ratio for the statement is changing over time. So the next one, Ann was already talking about the access path changes. I think especially when you're running a lot of dynamic SQL, I think everybody of you knows the issues what you have with dynamic SQL. For example, you're running a run stats and suddenly the next day the statement is no longer performing. Probably the day before it had some milliseconds and suddenly the statement is consuming some seconds, CPU seconds for the same execution. So most likely access path change happened in between, and that's one of the things SQL QC is focused on. So for example, the first picture is showing us in green a CPU consumption of 4,230 seconds. And then an access path change happened, and we see that suddenly the yellow one is going much, much higher. So that's the consumption of an SQL statement in a specified workload before and after. So it's easy to recognize what was happening to the SQL statement. And because we don't only have an key for the SQL statement itself, we have a key to the access path. So that's what we see in the middle of the slide. Sorry. There is a pass one and a pass two. This means we have a pass key for the statement before the access path change and after the access path change. All this information is available in tables. So it's quite easy in Grafana just to create a simple overview. We have an access path change here. What was the CPU consumption before? What is the CPU consumption today? How many executions we had for the statement? What will be the overall cost compared to the past, because we can compare everything here. We have the numbers, we have the execution numbers, we have the single execution CPU consumption, and this for each point in time where an explain and capture of the cache was executed. So it's quite easy to find out where an access plan change happened, how expensive it is now, which statements are hit by the access plan change, and which programs are hit by the access plan change, and so on. Ann was already describing that they are using the explain to find out what was changed, for example, in statement behavior. This is what we see in this picture as well. So we are combining permanently the elapsed time, the CPU time, and the access plan information. So what we see here is at the bottom of the slide, the estimates what the optimizer is believing how the statement should behave. So we see, for example, in green, the total cost for the statement. So we see a permanently increasing cost for the statement. In yellow, as additional information, the I/O cost. So we have the information available, what is the CPU estimate, what is the I/O estimate for the statement, and the history, how this changed over time. The table at the bottom, that's the typical information as it's available in if it were 316 and 401. So the elapsed time, CPU time, get page, synchronous I/O, global log weight, local weight, rows examined, rows processed, and so on, read list processing errors, and so on. So a lot of information. That's just a short extract here, what we can show on the slide here. But that's typically the way how we are combining the data, consumption data, with optimizer data, changes whenever change happened, what was the reason for the change, what was the access path before, what is the access path today, which index was used in the past, which index is used today. Here a short example how this index advisor is working. As mentioned, all statements which fulfill the criteria, for example, at least 1,000 CPU seconds per day, can be investigated. That's controlled by a filtering by an input SQL statement. And then the statements are investigated, and the result finally is written into a table. The table is, for example, shown again here in a Grafana panel. And the type of recommendation is, for example, the index advisor is looking for table space scans. Okay, that's quite simple. It's looking for stage 2 processing, for joins without index support, for indexes where additional columns should be added to improve the match calls, for example, or shifts within the index. For example, we have an index with 5 columns, so the recommendation, like in line 2 here, could be we should move the column from position 2 to position 1 to increase the match calls. So all these kind of improvements are generated, written to a table, and then made visible in Grafana. Good. There are a lot of additional information available. For example, okay, you can find this similar information in the real-time statistics. For example, you can look into the explain statistics. So, for example, what we see here is which indexes, for example, are not used. But the difference to real-time statistic here is that you can specify a specific time frame which should be investigated. Just imagine you would like to push a new product or project into production, and you are investigating which of the indexes, for example, are really not in use. All this restricted to a specific time, or you have a batch component, you have an online component, so you can investigate independent what indexes are used in the batch component and in the online component. So this is what as well is based on the explain statistics, which is created here on a frequent base. Good. Another thing what is currently being processed by us here is an impact analysis. So you could imagine, for example, finding out that adding or moving, yes, let's say moving an index column from position 2 to position 1 would be beneficial to one SQL query. I think that's very simple to find out. Always the question is, how does it impact my total workload? How is the impact on the full workload what I'm processing? For example, I'm moving such an index. So I'm changing the positions of the columns in an index. Yeah, for a single query, it's easy. For the full workload, it might be a disaster. So the question how it works for the full workload, for the full picture, the so-called impact analysis of SQL QC is a component which is helping to analyze it, because we can recalculate based on the estimations of the optimizer, we can recalculate the cost, the total cost before and the total cost after such a change. Or imagine you would like to drop an index, it's just the same. For a single SQL, probably not a problem, but for the full workload, it might be a completely different picture what we get after this. Good. This was a short overview of SQL QC. I think what we have seen from Rewe is a huge volume of data they are collecting, up to 150 billion SQL executions per day. That's really impressive. And this was for us as well impressive, because we had to redesign the product to manage this high volume. But okay, that's final. Closed now, that's finished. We have seen some examples what Rewe is expanding the products themselves. They are using Grafana and using the techniques of Grafana to create their own reports, what they would like to use. We are using, for example, here a lot of panels in SQL QC which are coming out of the box with a product. I think they should cover most of the requirements, but as you know, each company has some special requirements, so easily to expand if you know a little bit about Grafana and SQL, of course. So these are the components which are, I think, working quite good together now, helping out to find suddenly issues coming up by access path problems, for example, overnight. Just supporting the installation and finding out problems and fixing the problems as soon as possible. Good. Marcus, do we have any more questions? I don't see it in the moment. Just a second.
No, I don't think there's any more questions. There was just a sec. Are the statement stats derived from the statement cache or from SMF?
Statement cache, not from SMF. They're coming
Right.
directly from the statement cache. So this makes it quite cheap to get this information, and taking this information out of the dynamic statement cache is much more cheaper than putting it out of SMF.
Mm-hmm.
And we don't need expensive traces. I think that's one of the critical parts here, because starting SQL traces is 53, for example, so very expensive trace. Taking the dynamic statement cache or static statement cache is very expensive compared to this, very cheap compared to this.
Mm-hmm. And just for fairness, I'd just like to say that BMC's Aptune, Broadcom SysView, and IBM's Omegamon also do similar functions as SQL QC from UBS INA.
Yes, there are more products on the market. That's correct. Yes.
Yes. Thank you very much, Anne and Frank. That was really interesting, especially the import into Grafana, and have I think a visual impact, a visual display of performance improvements has a greater impact, especially for managers and others who are harder thinking. Great stuff. Thank you. Everybody, please don't forget to feedback. The session was no, it wasn't. 6p. The session 6p. Unless there are any questions, I'm sure you didn't. Unless there are any other questions, I'd like to thank Anne and Frank once more and give you a few more minutes back in your calendar before the next session.
A moment, let me just see. There are some more questions I have seen. Just a second, please. Okay, so there is one question from, I think the other one we already had. Do you explain regularly to see? Okay, I think this was answered by Anne already. The next one by Diren. So is there a start the task? No, we don't have a start the task anymore. It was a start the task in the past. So we currently have just batch jobs. For example, what Rayway is doing here, they are scheduling the batch jobs by the scheduler. So for all of the 12 data sharing members, so they are fired all 15 minutes, running for 1, 2, 3 minutes. I don't know exactly how much time it takes in the moment, but it's driven now by job scheduler, no more by start the task, which makes the handling much more easier, installation and all the stuff. Okay, the next question was statement derived. This one we answered already as a data collector. Yes. Can you load the dynamic SQL statements into another DB2 subsystem and do the analysis on the copy? Yes, of course, copy of the statements is possible, but this means that the Grafana configuration, for example, must point to the other subsystem as well, which is not a problem. But in general, yes, it's possible. Copy the data into another subsystem and adjusting the Grafana configuration to point to this subsystem. That's of course possible. But the problem then is running the explains, for example. The explains, of course, they depend on the subsystem where the or data sharing group where the workload was executed. Possible, but especially with explains, not recommendable. Okay, I think this was it.
Okay. Great. Thanks again. And don't forget to fill your feedback in. It allows us to provide more interesting content for yourselves, particularly next November when we have an in-person conference. So enjoy your break, and we shall see you in 45 minutes for the next session, which is DB2 application recovery tips, tricks, and best practices. Cheerio, everyone.
Thank you. Goodbye.
Thank you. Goodbye.